I'm going to do something a little bit different for our upcoming Unit 2 test. Unit 2 test is all on dilation, similarity, and introducing slope. So on our review that we received, I'm going to do a voiceover as I go over each of our questions. So number 1, it says, decide whether each statement is true or false, and explain why the false ones are false. So in letter A, it says, it is not possible for the dilation of a line segment to be the same length as the original line segment. So let's think about that when we're talking about scale factor on dilation. So I'm just going to underline some key words. So dilation, we're talking about not possible at all, and we're talking about being the same length. So can we come up with, we only need one way to prove that it is possible to make this not true. So, and off the top of my head, we can have a scale factor of 1. So our answer is going to be false. You could say a scale factor of 1 will make the line segment its original length. So we just proved that with a scale factor of 1, because 1 times, remember in scale factor we always multiply, 1 times the number, or any number, will be the number itself. So, so we just proved that if we just have a scale factor of 1, it's going to be the original length. Moving on to B. Dilations of perpendicular lines will be perpendicular lines. So what they're saying, a perpendicular line form 90 degrees. So if we remember, dilations don't change, do not change the angles measures. So we have a 90 degree. If we dilate that, it's still going to be 90 degrees. So they're still perpendicular lines. So this answer is going to be true. Letter C. In a dilation with a scale factor of 2, so that means it's going to be 2 times larger, an angle that was 30 will now be 60. So the correct way we dilate, the angle measures never change. Just the size, the length of the side lengths will change. So this is false. Angle measures never change in dilations. Angle measures never change, however, the length of the side length, they do change, unless we have a scale factor of 1, and that's the original. Letter D, dilations of a square, so we're talking about a square, are always similar to the original square. So we're going from, this is our original square, and we're dilating it, saying I'm going to make a square 2 times the size. I know my drawing's a little bit off, but will they always be similar? Yes, because the angles never change. They're always 90 degrees. That's the first thing. And then, being that if this is size 2 by 2 by 2 by 2, and we had a scale factor of 2, that means it's going to be 2 times 2 equals 4. So all of these would be 4. So we would have corresponding side lengths as proportional. So yes, this is true. Always, always, always for a square. Moving on. Down to number 2. Number 2 reads, which pair of triangles must always be similar. Explain how you know. So we're looking for they must always be similar. So if we can come up with one way they're not be similar, then we know it's false. So we have a triangle that has a 45 and a 70 degree angle, and another one that has a 45 and a 65 degree angle. Are they always going to be, will they always be similar? So let's find out what our third angle would be of this triangle. So if you remember, it has to be for triangle, let's just name this triangle A, and this is triangle B. So if we were going to figure this out, we'd have to say 45 plus 70 plus our third angle. I'm just going to label it N. Has to equal 180. So to solve this, we add these together. So 70 and 45 is 115. And we're going to subtract 180 minus 115. And we get 65. So our third angle is 65. So let's figure out if we have the same angles. So we have a 45 and a 45. We have a 65 and a 65. And we can test. If we know that two of the angles, corresponding angles, are congruent, the third one must also be congruent. So we can say the third angle in the first triangle, that's a triangle, is 65 degrees. So both triangles, shortening it up, have all congruent angles. Angles. So that little sign is angles. Letter B. It says triangle A that has a 20 degree and an 80 degree angles, and a triangle, second triangle, has a 20 and a 60. So we're going to do the same thing we did for part A to see if these work out. So what I'm going to do is I'm going to go 20 plus 80 plus blank has to equal 180. Well, 20 plus 80 is 100. We need 80 more. So our three angles are for triangle, let's say angle A, triangle A will be 80. And then for triangle B, it has to be 20 plus 60 plus blank equals 180. Well, 20 plus 60 is 80, so we need 100 more. So that'll be our third angle. So we can see the 20s are the same, but we don't have an 80 over here, and another 80, we don't have a 60, or we don't have a 100. So no, these are not going to be congruent, or they're not going to be similar. So you can say the triangles will only have one congruent angle. Comma, so they cannot be similar. So we just proved that B does not work. I want to cross out B. A did work. I'm just going to circle that one. C. It says two triangles that are both isosceles. Think of isosceles. And both have a 20 degree angle. So, if we had isosceles means we have two sides are congruent. So two of the side lengths are congruent. That also means two angles are congruent. So see if we can prove this wrong. We just need to come up with one way. And if we would have, say we had a 20 degree angle plus an 80 degree angle plus an 80 degree angle. 80 and 80 is 160 plus 20 more is 180. So this would be 180. So that's our first triangle. We have isosceles because we have two angles here that are congruent. This shows that they're isosceles. And one of the angles has to be 20. Now let's see if we can come up with another way. So if we had, what if we went 20 plus 20? Okay, now we have isosceles, so we have two angles that are the same. 20 plus 20 is 40, so we need to add another 140 degrees into that to get 180. So we just proved that we can have two isosceles triangles as different. So this could be wrong. You could make it work if you had a 20, 80, and 80, and then 20, 80, and 80. You could get it work that way. But we just proved one way that it doesn't work, and that's all we have to do. So this one does not work, and you could say they could be similar, but could be different. And we just proved how they can be different. And that's what we're looking for. So we just proved it this way. They're both isosceles triangles, but they have two different angle measures. One has 80s, and the other one has 20s. And then our last one, I crossed that one out. So right now, the only one that works is A. D, two triangles that have a 50-degree angle. So what we could do, it just varies. I mean, this one, I hope you can say right off the bat, it's not going to work. So you could say they would only have one congruent angle. For sure. But the other two angle pairs could be anything. With a sum means we added all three angles up of, if we know it's 50, 180 minus 50 is 130. So we have, as long as we have the other two angles add up to 130. So here's an example how we're going to prove it wrong. So we're looking at two different angles here. So we need to have a 50. And say I had a 30, so that's 80 plus 100. Okay, there's one. Now the other triangle has to have a 50, so I'm going to start with that. And say this time we had a 40, so we're at 90 now. And then what we have left, 50 plus 40 is 90. 180 minus 90 is 90. So they all equal 180. But we just proved that we can have different angle measures, a 30 and 100 and 40 and 90. In order to be considered similar, all three of these angles have to be, corresponding angles have to be congruent. So this one will not work. So we just found out A is the only one that works for us on this. But on your test, you're going to be asked to have in-depth explanation, just like we've had. All right, so let's turn to the next page. Just check the camera. All right, where it should be good. So in number 3, it says find the slopes of each line in the diagram. So many of these have slope triangles already for us. So we can just use this, except for, I guess, C and E don't. But that's okay. We can make our own. So all of these, we're going to remember what we're going to be doing for these to find slope. Slope equals the vertical distance over horizontal distance. All right, so if we're looking at letter A, our vertical distance, I'm only looking at my slope triangle. So if I zoom this in, it's 1 square, so we're up 1. There's our vertical distance. So, and then I'm going to find our horizontal. 1, 2, 3, 4, 5, 6. So I want to go over to for slope A. It's going to be our vertical distance over horizontal. Our vertical distance was 1, and our horizontal is 6. So it's going to be 1 over 6. Move over to B. There's a slope triangle already. Our vertical distance is 1, 2, 3, and our horizontal distance is 1, 2, 3. So our distance, our slope, vertical distance, and horizontal, our vertical distance was 3, our horizontal distance was 3, and I can reduce this. 3 divided by 3 is 1. Moving on to C. This one doesn't have a slope or a slope triangle. So what I'm going to do is on my line, I'm going to find where I find our line go exactly through an intersection point. And there's one here. I'm going to follow that line up to here. I'm going to pick those 2 points. You could pick other ones. You could pick, where else do they go? Here, follow it up to here. I mean, there's a series of them, but you only need to find 2. So I'm going to make my slope triangle. I'm going to go up this time and over. So my vertical distance is 1, 2, 3, 4. And my horizontal distance is 1. So I'll go to my answer. My vertical over horizontal. Our vertical was 4. Our horizontal was 1. 4 over 1 equals 4. Slope D. This one, our slope triangle's there. So my vertical distance is 1, 2, 3. My horizontal distance is 1, 2, 3, 4, 5, 6, 7. 3, 7. So I'll go to our answer. Slope of D, vertical over our horizontal. Our vertical, we said was 3. Our horizontal was 7. So it's going to be 3 over 7. And I can't reduce that. That's our answer. And then letter E, our last one. This one doesn't have a slope triangle either. So what I'm going to do is just find a point on here where it goes through at a corner. Here's the corner. Follow it to here. I can pick that, or I can pick here, 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 here. And I'm just going to make a slope triangle. And I want to zoom in a little bit further so you can see. Because this one's small. I want to rise 1, so this is a vertical distance of 1. Now I'm going to horizontal distance of 1, 2. So vertical distance of 1, horizontal of 2. Zoom out a little bit. Go to our answer. Vertical over horizontal. And we said our vertical distance is 1, horizontal was 2. And then letter F. It says now add in another line that has a slope of 3 over 5. So we need a vertical distance of 3, and we need a horizontal distance, H here, of 5. So I want to find a spot on here, and go in the bottom right hand corner, and I'm just going to put a dot right here. I'll zoom in. So I'm just going to write our slope. We need 3 over 5. vertical distance over horizontal. So from that point, I'm going to follow my vertical, which means I'm going to go up 3. 1, 2, 3. And then I'm not done yet. Now I have to do a horizontal, a 5. So I went up 3. 1, 2, 3, and now I'm going to go to the right 5. 1, 2, 3, 4, 5. I'll do it again, up 3, because it tells us vertical distance of 3, and then our horizontal distance of 5. 1, 2, 3, then 5 to the right. 1, 2, 3, 4, 5. We only need 2 points. Grab a ruler. We can draw our line through, and we're done. So this, I'm going to label it line F. All right, moving on down. I'm going to check the camera. So on number 4, what you're doing, it says, here are some polygons. It says, which polygons are similar to A? List all the possible choices. So I'm just going to highlight, this is A. This is where we're comparing everything off of. All right. So what we need to do, when we're talking about similar figures, we need to have 2 things. We need to have corresponding I'll zoom in. Angles congruent. That means equal. And the second thing, you need to have the same scale factor for all sides. Same scale factor. So that means if we have a scale factor of 2, that means all side lengths have to be multiplied by 2. Another way to do this is being able to do some type of transformation to land right on it. First of all, the shape has to be identical. Shape doesn't, has to be the same. So if we're looking at, for example, D, you see how this is different. So we know D is not going to be. All right, so what we're going to do is we need to decide which polygons B, D, C, E, and F are similar. So what we need to do is let's look at B. So if we had this shape, if we would need to rotate this, if I rotated this, so it's now facing the same direction. But then what we need to do is our angles. We have two 90-degree angles. Would they match up? So to do this, you could use tracing paper. Let me grab some tracing paper. So this is our original. So what I'm going to do is I'm just going to draw this. I'm going to freehand it. You probably should use a ruler. And we're going to make sure all our angles are congruent, our corresponding angles. So if we rotate this, I could pick any angle. Say I wanted to rotate around Y. Rotate this 90 degrees. So it'd be right about here. And then we had to translate to the right and up. And then we had to dilate. Dilate means shrink, right? All right, in this case, we want to shrink. It could be enlarge or shrink. So what we do is test all these angles. So what I'm going to do is I'm going to go over the top of these. So the 90s are easy to work out. And then I'm going to see if this nose piece is the same angle. Yep, that works. And then the bottom. So the angles all work. So the last thing that we need to test is see how much do we shrink? So we're going from A, our original, to B, our image. So our image is 1.5. And this, our original, is 1, 2, 3. So essentially we're going to be taking half the distance. So if we're going through 1 box, 2 boxes, so half of 2 boxes would be just 1. And that's what's happening here for both of these. 1 box, 2 box. So half of that. So B is going to work out. I'll circle it, and I'm going to put B over here. D doesn't look like anything like the original. It's too far over here. So we know this one's not going to work. Moving on to C. So here's our original. If I would rotate this, or I could reflect. Let's see. Let's reflect that. We can reflect it over our line WX, and we can translate it down and to the right. And then we have to dilate this thing. We got to figure out how many. So I'm just going to look at this side compared to the image below. So we know we're getting bigger. So the scale factor is going to be more than 1. So if I went there, it's 2 times bigger. So all our lengths of our original has to be 2 times the size. So if I match up there and there, that's 2 times. I want to do this, test this one. So there, drop it down. There's 2 times. What I'm looking at is the distance here that I could fit 2 times on the line, comparing it to our image. And then I want to do the side. 1, 2, that works. And then our top, 1, 2. So they all work. Scale factor 2. It's 2. Up here I put a scale SF equals 1/2. So we know that, and we tested all the angles. It's the same exact. 90s work. This angle works. Down here, this angle is the same. Down here, it's the same, and the 90s work. So we know C works. B and C. All right, let's test E. So this time, we're going from our original, and we need it to look like this. So I need to, if I rotate this, say I rotate it around X. Let's just see if it would work out. So what's different? Let's see. So what's different about this? So if I rotate this thing, and then I translate down and to the right, so that the image E is clearly bigger than our original. But what's different about this one, so the 90 works, this angle doesn't quite work. You see how it doesn't match up? We want to, maybe let's try this angle. Okay, this angle works down on the bottom. So this angle is what's throwing us off. These are not corresponding angles. So we know that E will not work. Lastly, is F. So it looks like we're just going to slide this thing down. 90, let's test our angles, that works. Test our middle one, that one works, and that one works. Now let's check our dilation. Looks like we're 1, 2.5. So scale factor 2.5. So it's scale factor 2.5, and let's just see if it works all the way around. There's 1, there's 2.5. And then if this side worked, this side's going to work. Now the one's going down, the diagonal, so 1, 2.5. Now it's going up on the diagonal, 1, 2.5. Yes, so we know that F also works. So I'll circle that one. So we have 3 similar figures. The question is, in B, it says choose one of the polygons you listed above and describe a sequence of transformations that takes polygon A to the selected polygon. I'm choosing polygon. All right, so we're going from A, and we need to pick one of the 3. It doesn't matter which one you pick. I'm going to pick, I'll do the last one we just did. So I'm going to pick letter F. So the first thing that I want to do, so I have my tracing paper. And what I'm going to first do is I'm going to translate point W. So if we look point W, and I want to translate it all the way down. And I'm going to put a letter here to make it easy. I'm going to pick letter M. So what I'm going to write is I'm going to translate point W to point F, which would be down. We had to figure it out. And I'll try zooming in. Oh, I guess you gotta be able to see. If we wanted to actually, we're always looking for the distance and direction. So to do that, we have to go down, and let's count how many down we have to go. So we're going from our original spot all the way down to here. So to do that, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, hold on one second. I'm getting mixed up with the page below. So let's go down again. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and a half. You can tell this bottom corner is halfway between. So we're down 17.5. So I'll zoom out a little bit. And we can say units. And then, so we're down 17 and a half. Then we're going to move to the right. And so that means I'm going to move 1, 2, 3 to the right. Then 3 right. Okay, so we mentioned we're going to translate, and we're moving down 17 and a half units, and then 3 to the right. Okay, we did that. So now we're at this point right there. So now we already figured out our scale factor of 2.5. So this is what we're going to write. Then dilate figure A with a scale factor of 2.5, and at the center, because we always need to have a center of dilation, where are we going to dilate from? So if you remember at the top, point W, I'm going to go our scale factor 2.5 times from that point. So everything from that point is going to be 2.5. Scale factor of 2.5. So our at the center W. And that would make our shape get 2.5 times bigger in every direction, going off this 7 point. Okay, moving on. Front and back left. So I'm just going to move my cameras a tad so it doesn't freeze up. Triangles ABC and XYZ. So we have our two triangles here. And they're saying they are similar. So we can assume that corresponding angles are going to be congruent and corresponding sides are going to be proportional or have the same scale factor. So it says find the line segment of BC and explain how you show your work. So we're trying to find out what this distance is right here. So let's find out what we know already. So the first thing you need to do is find corresponding side lengths. We know that corresponding angles are going to be congruent because that's what they already told us, because they are similar already. So we know that angle C, let's see here, B will be with both Y, but what we're going to do more importantly right now is we're going to look at our side lengths. This AC and 3 are corresponding side lengths. So I want to use those, and they're both known. And what I'm doing is I'm picking numbers, side lengths that we have. We know the measure value for both. And these are the only two that we know. We know this is 6, but we don't have 6 on either side. I'm sorry, we don't have a number on either side. So we can't use those. So what we're going to do is we're going to use this. We're going to set it up as a proportion. So I'm going to come up with, I'm going to go from my big triangle over my small. That's how I'm going to set it up. So my big triangle is the one on the right here. So what we know is, we know the big one had a 4.5, and it corresponds with this side length, 3. We're set it up just like that. And I'm going to set it equal. Now I want to know what BC is. So I'm going to write just BC. And BC goes with YZ. And that distance is 6, we know that. So there's a couple different ways we can figure this out. We can ask ourselves, well, what times 3 will get you to 6? Well, 3 times 2. So what we do to the bottom, we have to do to the top as well. So 4.5 times 2 equals 9. So 9 units would be our answer. Moving on to B, we're still using our same triangles. It says find the length of BA. So we're going to this one. So we know this is 9. Now we're going to our longest distance. So we're going to set it up very similar what we did for letter A. So we're going to go big triangle over the small. You can flip-flop them if you like, but so I'm going to use the same proportion we did before. So 4.5 over 3 equals, we need to find out our big triangle length. So I'm just going to say AB, and this corresponds with 7. I'll show you another way we can solve this is by cross multiplying. So if we went 3 times AB, that means 3AB. Then we went 7 times 4.5. That's 31.5. And then lastly, I want to solve for AB, so I want to get rid of my 3. I'm going to divide by 3. 31.5. Do this on the calculator. Divided by 3 equals 10.5. 10.5. So AB will equal 10.5 units. Moving on to number 6. Number 6 is all the points of this figure are on the same line. So all the points on this in the figure are on the same line. So you can see that we have a point here, here, and here. And it says find the slope of the line. So the very first thing that we should do is identify our points on the line that are given to us that have an ordered pair, that are given with numbers. We have an x and a y, x and a y. This one's not going to help us right now because we need to know numbers. Now, we can kind of guess, but we won't know exactly because it's not at an intersection point. It's hard to tell. So we're going to pick the ones that go at an intersection point, and I'm just going to make my slope triangle. So from here down to here, and then letter A says, well, find the slope of the line. So that's the first thing we're going to do. So remember, our slope triangle is going to be your vertical distance over your horizontal. Our vertical distance is 1, 2, 3, 4. Our horizontal is 1, 2, 3, 4, 5. So their answer, vertical was 4, horizontal is 5. So the answer is 4 over 5. Now we have to write an equation of this line. So to do that, we're going to look at our triangle. You can do it 2 different ways. I'm just going to look at this small triangle right here. So I'm going to bring this down, this over. I'm going to only look at this triangle right here. And what I need to do, being that if we look at our line doesn't go through the origin. The origin would be 0, 0, right where my pen's pointing. It goes out somewhere out here, 2 point something, 2.1, 2.2, right around there. So that's not going to help us. So what we're going to do, because of that, we need to find out our vertical distance and our horizontal difference. So what we do is vertical, we're looking at our y's. So I'm going to put y minus, and we're going to look at our ordered pair. Our ordered pair is x and a y. So we're going to, y's go together. We're going to subtract our y's. So y minus 7 will be our vertical distance. And then our horizontal distance will be x. We're going to subtract our x's. So x minus 6. So we're going to use those two, our vertical distance over our horizontal distance, to come up with our equation. So it would look like, zoom out. Our equation would look, we're going to look at this one and this one, we're going to put it together. So our equation would be y minus 7 over x minus 6. And we're going to set that equal to our slope, which we found out in letter A, 4 over 5. Or, so that's using the small triangle. Or, if you used the larger triangle, which I'll use a different, let's see, purple. We went down and we followed it to here. The other way, you don't have to do one of these. So once again, we're going to, this time we're going to look at our x and our y value down here. This point, 1, 3. So over here, for our big distance of our, when I say big distance, I mean for our large triangle, it's going to be y minus my y value over here. My y value is 3. So it'll be y minus 3. And down here, it's going to be x minus our x value of 1. So you can have over here, the other way, you can say your vertical distance of y minus 3 over x minus 1. So y minus 3 over x minus 1, and we're going to set that equal to 4 over 5. Either one of these answers is correct. You don't need to do both, just depending on how you made your triangles. So now our next point is in C, is you have to see if point 1111 land on the line? So if we look at our graph, we could look at here over 11 and up 11. Is it going to land on the graph? Yes, it will, just by looking at it. But we have to show mathematically. So what we're going to do is we're going to pick one of our two equations we came up with. Doesn't matter which one you pick. I want to pick the first one here, just because it's first. I want to use y minus 7 over x minus 6, and which has to equal 4 over 5. So what I'm going to do is I'm going to substitute. Here's my x value and y value. I'm going to substitute my 11 in for my x, and I'm going to substitute my other 11 in for my y. So it would look like this. 11 minus 7 over 11 minus 6. 11 minus 7 is 4. 11 minus 6 is 5. Do they match up? Yes, they do. They have the same slope of 4 over 5. So yes. So how we would explain this? We just showed it mathematically, but we'd write yes because substituting so point 1111 in for x and y makes the equation true. And our last one on this page, number 6D, same thing. We have to substitute 16 and 18, so there's our x and a y. This time, I'm going to choose, I guess you can use that same equation if you'd like. You could use this equation too, if you'd like. Actually, I'll do that. I'll pick the other one if you chose to do this. So here's our equation, y minus 3 over x minus 1, and it has to equal 4 over 5. We're going to test our x. We're going to put where our x is. We're going to substitute it in, and our 18 is going to go for our y. So in this case, it's going to be 18 minus 3 over 16 minus 1. 18 minus 3 is 15. 16 minus 1 is 15. 15 over 15 is 1. Does 1 equal 4.5? I'm sorry, 4 over 5? No, it does not. So, all right, to write that, we can say no, because plugging in 16, 18, plugging in because, I'm sorry, no, because plugging in 16, 18 for x and y does not make the equation true. Moving on to the last page. Number 7 reads, here's a polygon. And what we need to do, it says, draw the dilation of wxyz using center of 0, 0 with a scale factor of 1/2. Label the dilated image. So what we're going to do is our center is right here. And it should tell you, this is our original. So I'm going to make my original figure here. We call this the pre-image. And then we're going to use a scale factor of 1/2. We have learned that a scale factor, if it's less than 1, it's going to shrink. So this shape, we're going to have the same exact shape, but just much smaller. So how do we do that? So there's a couple different ways you can do it. You can count how many, the distance away. So I'm going to look at my origin. My center is at 0, 0. So I'm going off the center for all my distances. So I'm going to go to my y first. So it looks like I'm going up 1 and over 1, 2. So I'm going to take the half the distance for each one of those. Well, half of 1 is a half, and half of 2 is 1. So point y, which would be now y prime, will be right there. And it should, if you make an array, it should line right up. We're going to do that for each letter. Now I'm going to move on to z. Z, starting at our origin, I'm down 2, so half of 2 is 1, so it's going to be on this line somewhere. And then we're over 1, 2, 3, 4. Well, half of 4 is 2. So if you meant down 1, over 2. And you could see that this is array, it's going to go right through z. Doing w, we're down 2 and over 2. So half of 2 is 1, half of 2 is 1. So it's going to fall right here. And then x, it's up 1, so it's halfway, so it's going to fall somewhere around here. And over 1, 2, so half of 2 is 1. So let's start here, go to here, and we have our shape. We just completed a diagram, or a dilation. So this would become, this point would be x prime, w prime, z prime, and I already have y prime. So we shrunk it with a scale factor, but SF equals 1/2. That's it, all we have to do for that problem. Okay, moving on to our bottom one. All right, our bottom one says...
Hi, sorry. So I have a student having